All right, so good morning. I'm Dr. Janish Patel. Um, so today I will be talking about the structure of an atom and what are the historical developments on the structure of this atom. There has been tremendous efforts made by various scientists to develop to understand the structure of an atom. So if you look at the ancient history in the ancient Greece time, there were philosophers like Aristotle, Democritus. So they proposed certain theories. So for example, Democritus said that uh, matter is made up of an individual particles, which is called atoms. Whereas if you see on the opposite side, the Aristotle said that the matter is continuous and it is infinitely divisible. So there were two different views. Uh, and then if you go further, there was discovery of an electron by Sir J.J. Thomson. So he performed an experiment with cathode ray tubes which concluded that rays were composed of negatively charged particles, and these negatively charged particles Thomson called them as an electrons, which actually created the theory of the existence of subatomic particles. So Thomson was the first who provided the existence of subatomic particles, electron. And then there were a few other scientists such as Rutherford, and they proposed certain different atomic models. Now one of the atomic model that was proposed by Thomson was the plum pudding model of an atom. So it says that there is a positive sphere. He proposed that the atom was a sphere of a positively charged material with electrons embedded in it. All right, so it's almost like a plum, the fruit plum, or let's say even watermelon. So watermelon has a fruit inside, and I mean the seeds of watermelon are embedded in the inside the watermelon. So in the same way, Thomson proposed that this atom is like a watermelon. So inside the watermelon, the red fruit is actually nothing but the positively charged material, and these black seeds, so these are nothing but the electrons. So these electrons are like scattered and they are distributed throughout the positively charged sphere, right? But this was not true. After a few years, Rutherford, which was one of his followers, he performed certain experiments. One of his famous experiment, which is known as gold foil experiment. So this gold foil experiment he performed with the help of the alpha particle. So what he did was that there was a thin gold foil. Okay, so thin gold foil was kept on one side, and from the other side the alpha particles, which are positively charged particles, and they were bombarded on this gold foil. Okay, and surrounding this gold foil he put the detector. And when he performed the experiment, he found some shocking results. Okay, so when alpha particles are being bombarded on this thin gold foil, so majority of these alpha particles, they will just straight pass through. Okay, but some of the particles, they were deflected at large angles, or even some particles even bounced back, and this was very shocking for him. And this led to the conclusion for Rutherford that atom has a small, very small, tiny, dense, positively charged nucleus in the center. So Rutherford was the first one who proposed that atom has a nucleus in the center, which is very dense, which is very small, and it is made up of positively charged particles. Okay, and then there was Niels Bohr. After a few years, he proposed the Bohr model of an atom. So what he said that electron actually electron is orbiting around the nucleus. So in the center of the atom there is a positively charged nucleus, and electron is orbiting. Electron is orbiting around this nucleus, and the path of this electron is actually very specific. It is very specific. this electron is moving in a quantized energy levels. These energy levels are quantized. So, that was proposed by Niels Bohr. That was one thing, and another thing was that he proposed that there are energy transitions. So, electron can jump from one energy level to the another energy level by either absorbing the photon or by emitting the photon. So, if electron is in the lower energy state, lower energy level, he can absorb the photon and it can go in the higher energy state. And if electron is in high energy state, it can actually emit the photon and it can come down to the lower energy state. So, this was the proposal that was put forwarded by Bohr model, I mean Niels Bohr. But there were few flaws in this model also. Then this model was modified by the Sommerfeld. Sommerfeld proposed that instead of electron moving in a circular fashion, he said that electron can move in an elliptical orbits. Electron can move in an elliptical orbits, and he did all those calculations what Bohr performed after considering the elliptical orbit of an electron, but he concluded almost the similar result to the Bohr, which said that energy is quantized. So, this Bohr model was and even Sommerfeld model was capable to explain certain experimental findings, such as the spectral lines of hydrogen atom. If you look at the spectral lines of the hydrogen atom, then these spectral lines are actually positioned at different wave numbers, and out of these few, like there are different different hydrogen lines. There are Lyman series, Balmer series, Paschen series. These are all different names. I mean, depend based on the scientists who invented those spectral lines. So, out of this one particular line, if you pick up the Balmer series, so Balmer series has also another different component. So, H alpha line, H beta line, H gamma line, and so on. So, H alpha line, if you see the H alpha line, then H alpha line is actually made up of two different lines. It is not a single line, but it is made up of two different lines. So, this splitting of these energy levels, that was not being explained by this Bohr model atom. Bohr model atom, Sommerfeld model atom, that this model could not explain why these energy levels are the spectral lines are splitting up into two levels. Okay. So, then there was development in quantum physics. So, quantum mechanical model was proposed. So, Schrodinger, he was the first one who actually created this idea of the quantum mechanics. So, he proposed the Schrodinger equation, which is a differential equation that represents the given particle that exhibits a wave like character. So, over here the wave particle duality was introduced. The wave particle duality was introduced. De Broglie was the first one who proposed that hypothesis, that a particle can behave as a wave also. So, this description led to the quantum mechanical model, and according to this quantum mechanical model, electrons are actually not in the fixed orbits, okay, but rather they are in a probability distribution, which is also known as an electron cloud. So, electron is not moving in a fixed orbit as mentioned by the Bohr or even Sommerfeld, but electrons have a probability in nearby region of this nucleus. So, in different positions the electron probability can be calculated. So, that was the quantum mechanical model, and this was the successful model that explained all the experimental findings, why this spectral line is splitting up into two, why you have H alpha line has two different lines, okay, and also some other phenomenon such as Zeeman effect. So, when you observe these spectral lines in the presence of a magnetic field, then these spectral lines are actually appear to be splitting up. Spectral lines will actually split up if you put the magnetic field near to the source. So, this splitting up of the spectral lines in the presence of the magnetic field, that was also successfully explained by this quantum mechanical model. So, this quantum mechanical model was of great success, and it is even working today, because this was described in 1928, 1927, 1928 somewhere around, and this model is still successful today. It is still answering most of the experimental findings that we are having while you are performing experiments with the structure of an atom. Okay, so still the progress is going on. Okay, so the finding, the last finding of this quantum mechanical model said that electrons there are particles called protons inside the nucleus which are positively charged. There are particles called neutrons which are neutral, they do not have any charge, they are in the nucleus, and there are electrons which has a negative charge, their orbits in the nucleus, and there are different shells. There are different shells in which you will find these electrons, rather the probabilities that electrons would be there. So, what is the current scenario if we see? So, in current scenario, the quantum field theory, which describes the particles as excitations of the quantum fields and explores the interaction between these excitons. And there are another branch which is the particle physics, which investigates the fundamental building blocks of the matter and what are the forces that governs these particles. Okay. So, these are the ongoing explorations of the atomic structure, and based on this current status of the electron configurations, we made the periodic table and atomic structure. So, each element's position on the periodic table, it corresponds to its atomic number, which represents the number of proton in the nucleus. And the second important aspect is the electron configuration, how the electrons are arranged. The arrangement of electrons in different energy levels is related to the elements reactivity and chemical properties. So, that is the current scenario based on which the entire chemistry is working, the entire chemistry which is based on the explanation of these electronic configurations. So, this is all about the structure of an atom. We have seen quickly from early ancient Greece time and till today what is the historical development of on the explanation of the structure of an atom. Hope you find it interesting. You can refer to various books to understand these topics, such as the book that is given by Bransden and Jostein, The Physics of Atoms and Molecules by Bransden and Jostein. Okay, that is one book. Another book which is given by the Rajkumar, The Atomic and Molecular Physics by Rajkumar. So, you can explore these books and you can see further developments made in this field. So, thank you very much. Thank you for your attention.